everyone, we're going to apply the difference quotient, which is this right here, to the following equations. We have two polynomials, and then apply the limit. That's going to give us our derivative, f prime of x. So this is an introduction to the derivative, and we're using simple polynomials. Before we get started, the main thing you need to know is that we're going to take the numerator in two parts. So basically when I do f of x plus h, that means I take this equation and input x plus h. And then I'm going to do the second part, means subtract the whole equation, which would be x squared minus 3x. So that's how you see that. The numerator, you have basically two parts to it, then we divide by h. So let's get started. Our first equation is f of x equals x squared minus 3x. So the first thing I do is the first part of the equation. I get x squared minus 3x. And I'm going to input x plus h because we want to find f of x plus h. X plus h, x plus h. Minus your whole equation, which is x squared minus 3x. All right. And that's all divided by h. And then we apply the limit as h approaches 0. Now, you can have a lot of these, so there's your little factoring facts. So let's just expand. You get x squared plus 2xh plus h squared minus 3x minus 3h. And the second part is going to be minus x squared plus 3x, all divided by h. Now, the rule of thumb is when you do this, everything should cancel out except if it has an h in it. If it doesn't, you did something wrong. So here's the h variables. Everything else should cancel out. So the x squares cancel out and the 3x's cancel out. And we're left with the limit as h approaches 0 of 2xh plus h squared minus 3h divided by h. Second step is to do your greatest common factor or your highest common factor and fact out in h. 2x plus h minus 3 divided by h. Now what's going to happen is the h's cancel, so we're going to get 2x plus h minus 3. So the limit of 2x plus h minus 3 as h approaches 0. And when you apply the limit now, plug that 0 in, you're going to get 2x minus 3. That's your answer. Therefore, f of x equals x squared minus 3x. So the derivative of f of x, or f prime of x, equals 2x minus 3. All right, the next one. We do the same thing. I'm going to take my equation. Everywhere there's an x, I'm going to put parentheses minus 1 there. So there's that equation. And I'm going to input x plus h. So let me write this bigger here. This is f of x equals x squared plus 2x minus 1. So I just wrote out the equations, and I put parentheses for my x, and now I'm doing my f of x plus h. So I'm plugging that in for my x's. The second part means you just subtract your whole function, which is x squared plus 2x minus 1. And this is all divided by h. Apply the limit as h approaches 0. And then we're going to write it again and simplify our numerator as x squared plus 2xh plus h squared. plus 2x plus 2h minus 1 minus x squared minus 2x plus 1, all divided by h. Now again, everything should cancel out if it doesn't have an h. The only things that shouldn't cancel out are the ones with the h's. So my x squares, my 1's, and my 2x's should cancel out. And they did. That tells you you did it right. Now looking at this, let's go ahead and write out 2xh plus h squared plus 2h divided by h. Next, factor out the h. So you're going to get h times 2x plus h plus 2 divided by h. Now the h's cancels and you're going to get 2x plus h, plus 2. You always have to apply the limit because the domain changed there when we canceled out the h's. So apply your 0 here, and that's going to give you 2x plus 2. Again, this is what it says. When you have f of x equals x squared plus 2x minus 1, then the derivative f prime of x equals 2x plus 2. And that's it. Thank you. Have a nice day. Bye-bye.